Hello and welcome to SudoKanard. We're here to solve one puzzle from the first round of Sudoku Grand Prix of 2026. This round was made by Turkish authors and especially Can Erturan, a young author who distinguished himself. I don't remember whether it was last year or the year before, and he had very beautiful puzzles and he did a great job again. So this is called Divisible Neighbour Sums, and the special rule here is that such a shaded cell means that the digit in this cell divides the sum of all adjacent digits, and it means laterally adjacent digits, so those three digits in this case. And all such cells are given, which means that 2 does not divide the sum of all 4 cells here. And knowing that all possible gray cells are given, we see that every 1 must be marked. 1 will always divide the sum of the adjacent cells. So if you have only one shaded cell in a box, it must contain the 1, like this. Now the rules of Sudoku prevents this from being a 1, so that is a 1, and then that is a 1, and then this, and then this, and then this, and this. So all 1s are placed. This is not quite the end of the puzzle, but that is definitely a nice start. So where do we move from here? Where do we move from here? And that's a real question. So there are not that many shaded cells. And an interesting point here is that this must be a divisor of the sum of those 3 digits. So this must be the sum of those 3 digits. For example, this could be a 5 and this a 3. Well, not a 5, this is taken. But this is 2 more than that. So 3, 5 doesn't work. 4, 6 would work. 5, 7, 6, 8. I'm not sure this is worth pencil marking, but I will do it anyway. So something of interest here. An unshaded 2 is always interesting because it means that here we have an odd number of odd digits. But this is probably too early to take this into account. So, well, let's do some Sudoku. This is 5 or 8. Just considering the digits in the row and the column. And that's interesting because the sum here is 24, which is divisible by 8. This is unshaded, so this can only be a 5. And here we have 3, 6, and 8. Likewise, let's see, the sum here is 27, which is divisible by 3, so we can remove 3 from this cell. 6 and 8 both work. 7 here will always work, whatever we put in here. 2 and 3 are not in here, so this is either 5 or 4 or 8, sorry. Those are from 2, 3, 4, and 8, which is kind of interesting. Not sure how. I think that 3 here wouldn't work, because then we would have a sum of 13, which could never be divisible by this. So this is from 2, 4, 8. This is now either 12, 14, or 18. 14 or 18, so this is never divisible by 8, but it could be divisible by any of the others. Here we have digits from 4, 7, 8. And we can do the same here. The sum is 14. 14 is divisible by 7, so 7 can be removed here, and 7 goes there. And both 4 and 8 work in this position. And Sudoku tells us that this is 8, actually. So that this is 4, this is 8, that's not 8. Here we have 7 and 9, and actually because of this we have a 7 here and a 9 there. So always remember to do classic Sudoku in a Sudoku puzzle. It can be very helpful. For example, you can place a 9 here. You know there will be a 9 somewhere in there. All right, and a 9 somewhere in there. Now this 3 is interesting because here we have 12, so this must not be divisible by 3, which was already the case anyway. So this is absolutely not interesting. Here we have a sum of 21, which is divisible by 7, so whatever we put in here, this 7 will be correct. Oh, by the way, this is from 2, 3, and 4. We can see that the sum of those 3 digits is either 19 or 21, which means that 2 here doesn't work. 2 would turn the digits into that, and here we would have 3 dividing 21, which is forbidden because this digit is unshaded. Would 4 work? 3 and 2. Here we would have 18, which is not divisible by 4. So 4 doesn't work, that's a 2. And now this is 12, so 3 and 4 both work, and 3 and 4 both work in the negative sense. Here, 9 is around here, so those are from 3, 5, and 8. What about this? Here we have 14. So this can't be 1, 4, or 7, which only forbids 7, which means that this 7 goes there. That's not 7, so that this is not 5. What did I do? That's a difference of... What did I do? This must be 2 more than that. So we could only have 6 and 4 actually. Only this works with the remaining options for this cell. So that this is 3 and this is 4. And here we have digits from 5, 8, and 9. Here we have all even digits. 2 is not in here, that's not 4, that's not 6. Those will always work because the sum of the neighbors is odd. This is an even digit, so this must be odd, which means that this has to be a 3. So we can remove this 3 and place a 3 there, which might be interesting in the long run. Oh, 5 here would turn this into an 8, which would have to be shaded. So that's not a 5. By the way, 9 is in here. Those are from 4, 5, 8. And there will be a 2 in here. Unshaded 2. That's interesting. That's not a 4. Here we have 5, 6, and 9. Well, not sure where to look next. perhaps this 2. Oh yes, this 2 means that the sum here must be odd, unshaded 2, so that this can't be a 5. So 5 is here. And whatever we put here, this 5 will be correct. But 3 wouldn't work with a 9 here. The sum would be 21, which would be divisible by 3. So that's 8 and that's 9. And that's a 6. This is 6. No, 6 never divides this. 3 must divide the sum of those. So this can't be a 4. And that has to be a 4. 8 here would turn the sum into 12, which would break. So that's a 2, that's an 8. By the way, that's a 6. So that's a 3, and that's an 8. Here we get a 2 by the rules of Sudoku. And here we need, let's take this 5, which does not belong in here. So this is 7 or 8. 8 inside this box. 8 goes there. So this is 7, this is 5, this is, I said 8. I said 7, but that was 8 actually. And this 5 works. The sum is 20 here. Here we need 2 and 7. There's a 2. So 2 here, 7 there. Here we need 5 and 3. 3 here would make the sum 15, which would break. I won't check everything. I will assume that if I made no mistake, then this works. So we get 9 and 8 using this 9 here. Here we need 3, 4, 6. And that's not a 3. Here we need 3, 4, 8. And that's not 8. Here we need 2, 5, and 6. That's not 2, that's not 5. And there's no 8 in here. And here we need 2, 6, 8. We can remove this 2, we can remove this 8. Here we get a 2, 6 pair, so we can remove the 6 from there. And then what? Not sure where to look. Perhaps this one or this one. Well, perhaps this 7. Here we have 9. This, no, the sum is never a multiple of 7. Well, 6 here would turn this into 8. That would totally work. 7 here. We have 21. I already mentioned this. This also works. That's not a 3. 7 here. We have 19. That was this 2. Here we have an odd total. The total of 4 digits must be odd, so this can't be the 3. That's the 3. And this is 4, 6, and 3. So I'm using more negative rule than the actual rule, you might say. Perhaps I should use the actual rule here. I'm tempted to test everything, but I'm sure it will be easier to just find something that doesn't work. Yes, here. The sum of those 3 digits is divisible by 3, so this must not be divisible by 3. So that's a 2, 5, 6, 8, 2, and 6. And now this 2 must have an odd sum, so this must be even. And actually, I didn't need to do that. And this is wrong. Wait. This is wrong. What is happening? That's the moment I take this This, you see, that's the actual. So, what is wrong with what I've done? Well, I'm looking at my solution when I solved it on paper, and I'm finding exactly the same digits in the same places, which means that the mistake was made when I created this interface. Well, I think this wraps it up. This is a solution to this puzzle, which was kind of smooth, and I think that for 91 points, it went pretty smoothly. So it was, I would say 91 points was pretty generous for this puzzle, which was, at any rate, very nice. Thanks for watching this video. See you soon on SudoKanard.